Application of integral. A population of insects increased at a rate of 150 plus 6t plus 15t squared insects per day. Find the total insect population after 3 days, assuming that there are 45 insects at time t equals 0 days. Notice that the rate of the growth is a continuous function. Okay, so if we're using a pre-calculus approach, the growth will just equals the rate times time. But right here, the rate is a continuous function instead of a flat rate. So we have to use a calculus approach. We have to integrate the rate from the beginning of time to the end times dt, okay, differential of the time. So here the growth will equal integral from day 0 to day 3. How many more insects are there? Okay, it's 150 plus 6t plus 15t squared dt. Now use the fundamental theorem of calculus. We find the antiderivative, so it's 150t plus 3t squared plus 5t to the third power. We evaluate from 0 to 3. Okay, so we plug in 3, we get 450 plus 27 plus 135. We subtract when we plug in 0, altogether it's just 0. So the growth is 612 insects. However, it asks you, what is the population at the end? The population will equal the beginning plus the growth, and it will be 657 insects at the end.